In 2014, India stunned the world when it triumphed with its unmanned spacecraft Mangalyaan, reaching Mars at a cost of $74 million. The single biggest challenge to making space accessible is the astronomical cost of space travel. The entire mission cost ISRO 800 crore, while the Hollywood blockbuster cost 1062 crore. How exactly does ISRO manage to keep the cost down? Recently, ISRO, the Indian Space and Research Organization, launched its heaviest satellite, the GSLV Mk3, also called the Geosynchronous Satellite Launch Vehicle Mark III. Not only was this a maiden flight for India's heaviest launch vehicle till date, it was coupled by performing a multi-satellite mission, sending 36 OneWeb satellites into the lower Earth orbit. ISRO has been at the forefront of technological progress in space for India ever since its inception in 1969, with the vision to develop and harness space technology in national development, while pursuing planetary exploration and space science research. But something that surpasses ISRO's tremendous ability to deliver for the nation is their economical approach to space exploration. Be it the Mangalyaan, with the entire mission budgeted under $75 million, or the Chandrayaan mission with a total budget of less than $50 million. The single biggest challenge to making space accessible is the astronomical cost of space travel, as admitted by none other than Elon Musk himself. So, how exactly does ISRO manage to keep the cost down, all the while maintaining an exceptional success rate, as evident by the success of the Mangalyaan mission in the very first attempt? How does ISRO achieve what other agencies cannot, even beating private players when it comes to cost effectiveness? In this video, we will break down the main reasons for the economical success along with technological success for ISRO. On October 22, 2008, India's first mission to Moon, Chandrayaan-1, was launched successfully from Sriharikota. Almost 10 years after that historic moment, the Indian Space Research Organization landed its Chandrayaan-2 on the Moon. And interestingly, the mission was cheaper than Hollywood's 2014 blockbuster science fiction, Interstellar. The entire mission cost ISRO 800 crore, while the Hollywood blockbuster cost 1062 crore or 165 million, the Times of India noted. Similarly, in 2014, India stunned the world when it triumphed with its unmanned spacecraft Mangalyaan, reaching Mars at a cost of $74 million, a fraction of the 671 millions spent by NASA on similar missions, and far cheaper than the budget of the Hollywood space blockbuster, Gravity. So how exactly does ISRO manage to do so? Let's find out. Reason number 1. Effective production techniques. Simplifying the system, miniaturizing the complex systems, strict quality control, and maximizing output from products make our space missions frugal and cost-effective. We keep strict vigil on each and every stage of development for a spacecraft or rocket, and therefore we are able to avoid wastage of products, which helps us minimize the mission cost, said K. Sivan, ISRO chief, describing effective production as one of the main reasons behind the inexpensive nature of the organization. These statements imply that ISRO keeps a close watch on the production of every component, so the defective pieces are eliminated entirely. Considering the complexity of a spacecraft and the number of components involved, this would certainly go a long way in conserving cost. Reason number 2. Low labor cost. India has some of the lowest labor cost in the world. Despite the low labor cost, the quality of highly skilled labor in India is next to none. The country can boast of producing top-tier talent working across the globe in various technical fields. This is a crucial advantage for ISRO, impacting the cost of production significantly. Reason number 3. Inexpensive payload and use of gravity. One reason for the lower cost of the ISRO's space missions as compared to other space agencies is the relatively inexpensive payload. The payload is essentially the equipment that a spacecraft carries along with it to perform various tests. Chandrayaan-2's payload included simple, light, inexpensive instruments such as a soft X-ray spectrometer, solar X-ray monitor, and an IR spectrometer, amongst others. Compared to this, NASA's Apollo 17 the space giant's last manned moon mission carried instruments for a biological cosmic ray experiment, a laser altimeter, a traverse gravitymeter, and many more. While the function of each of these instruments is beyond the scope of this video, one thing is pretty clear. These payloads were greater in number and combined weight than those hosted by Chandrayaan 2. These instruments significantly contributed to the total cost of Apollo 17. Chandrayaan took around 40 days to reach the moon, which is longer than any other lunar probe. In this process, it maximized the use of the gravitational pull between the moon and the Earth to gain velocity by increasing the number of orbits it made around the Earth. As such, the amount of fuel required for pushing it out of our planet's orbit was comparatively low and helped in reducing the total cost. A smaller amount of fuel also reduced its total weight. These are some of the main reasons why ISRO has been able to keep the cost of its space missions down. There are of course many other nuanced reasons, but I tried to cover the basics in this video. It is a matter of pride for the nation that an institution is not just committed to take the nation forward in space technology, but is equally committed to respect the taxpayer and be as cost-effective as possible. If you enjoyed the video, make sure to like it. Also, subscribe to the channel. Take care of yourself and your families. God bless us all. Thank you.